All right, I'm gonna get started right now. So today we're presenting reverse engineering setup. Actually, let's do this first. So again, my name is Cameron Asher. You should all know me by now. I'm the president of this club. I'm a statistics and computer science major. And last time I put my face, so this time you get my Discord profile picture. If you see that guy on Discord, it's this guy in real life. And there's my fun fact. I got this commissioned by an artist in 2018. You can do the math on how old that was. And it's based on the default YouTube profile picture. So if it looks familiar, I had just like randomly generated the purple default profile picture. Right, announcements, Fall CTF 2025 is this Sunday, so starts at 12, doors open at 11:30. So if you want to get there a little early to get set up, you can come at 11:30 and go to 2025.fallctf.com to see all the rules. Now we have what prizes are up, so if you're interested, you can see that. And if you haven't heard of Fall CTF somehow by now, this is our beginner cybersecurity competition. There's going to be prizes, there's free food. We have recruiters from Red Lattice, Patel, and John Deere coming. So if you want to talk to them, they'll be at the event too. So I recommend coming out. And then Seesaw CTF 2025, raise your hand if you were there playing in the Seesaw calls. There were a few of you. We did end up qualifying for finals this year, so thank you to anyone who participated. It was close, but we managed to do it. Here's the meeting flag. Everyone here should come to Fall CTF. It's on a Sunday. You can make it. Here's my moment to say the slides for this meeting are already posted. So if you go to sigpwny.com/meetings, you can download the slides, and I recommend doing that around now too, because the way I'm going to do this meeting is I'm going to rush through all of the setup. So you might not have time to run every command. Maybe you run into an issue and then you get stuck. And at the end, you're going to be able to have as much time as you need to ask our helpers any questions. And you can take your time going through the slides that you downloaded off the website and running the commands one by one. So you don't have to worry about typing them yourself off the slides. You can just copy paste into your terminal. It'll be no problem. Yeah, so sigpwny.com/meetings, download the slides now. And that also means you don't have to copy the meeting flag. Like you don't have to type it. You can just copy paste it into the C2A. That was a question? Yeah, you can practice for full CTF on our internal CTF. Someone posted a link in the chat on Zoom. Right. So now I'm getting started. So raise your hand if you came to our first setup meeting. It's like a few Sundays ago. All right, most of you. So raise your hand if you have Python installed. Most of you. Raise your hand if you used pym to install Python. Some of you. Raise your hand if you have Docker installed. Like half. Okay, so some of you will need to do that. Raise your hand if you have Ghidra installed. Like a quarter. Okay. So these slides will be relevant to. And raise your hand if you have pwntools installed. All right. If you're coming to full CTF, which is all of you, you're going to need all of those things installed. So this is your chance to get help from helpers before the competition starts. Fall CTF is a timed event. So you don't want to be wasting your time installing tooling. Might as well get it done today. All right, what is Ghidra? I just talked about it. Ghidra is a reverse engineering toolkit developed by the NSA. So you can say you're using NSA built software, but it's open source so anyone can use it. And it lets you disassemble applications, so the actual binaries. So if you ever used a compiled language, they generate a binary in the end. And Ghidra is a tool that you can take that binary and turn it back into something that looks like C. So you can read it, understand what is actually happening in this application. Yeah, so Ghidra is written in Java, so you're going to need Java installed. Again, you can try running this, but I'm going to run through these slides. So yeah, once you downloaded these slides, you can download Java. I gave you a link. Ghidra recommends that you use Java 21. Like that's what it recommends on their GitHub. But versions later than that will probably work. I haven't tested it, so I can't confirm it'll work on 22 through 25. But if you're downloading Java from scratch, just download JDK 21. That will for sure work with Ghidra. And in Linux, it's easier, as it usually is with programming things. Right. So once you get Java installed, again, once you have the slides downloaded, click on this link to go to the NSA's GitHub. Very fun. This is the open source stuff, so the less cool things are. And if you click this link, the .zip, I gave a nice red arrow so you can find it quickly. I know people love red arrows. So download the .zip file from here and then unzip it. And then that's how you will install Ghidra. Yeah, you'll see this Ghidra run.bat on Windows, so you're gonna wanna run that. And then on Mac, you're gonna wanna open the terminal and run these commands. The question marks will actually work, a cool bash trick that we'll teach you later. But yeah, if you have these slides downloaded, you could literally copy paste this in your terminal and it should get Ghidra up and running. Yeah.
There was any way to install it, so it's like you have like search for it, or do you just use the bash?
I don't remember off the top of my head, probably.
You can alias Ghidra equals run that script with absolute path. Ghidra.
We'll figure it out at the end. All right. So Mac OS is annoying because Ghidra is unsigned. It may give you an error. Just follow these instructions. If you don't find the text instructions clear, click on this link. It should tell you how to fix it. It's pretty straightforward. You just have to force Mac OS to let you run it. I can guarantee Ghidra is safe. All right, pwntools. So pwntools is a CTF framework. It's written in Python and you interact with it in Python. It makes scripting things much easier and you use it for Rev and Pwn challenges and sometimes web challenges too. So I recommend learning it. It's kind of a whole process, but you'll need it if you ever do Rev or Pwn challenges. Here are the instructions again for pym. I think most of you already have Python installed, so as long as you have some version of Python installed, it should work fine. I know one issue people were having was that you had to add, like after running this command, it gives you a little string of bash script that starts with export. You have to add this to your bashrc, or if you're on Mac, your zshrc, in order to get it to, like, if you make a new terminal instance, to have pym running. But if you have Python installed, just ignore this slide when you're going over afterwards. And pwntools should be pretty straightforward to install. You can just run pip install pwntools or python 3-m pip install pwntools. Should work. There's like a million different errors that could happen when you're doing this, depending on your system, what version of the Mac you're on, if you're on Windows or Linux. So if you do end up having an issue with this, raise your hand to help overcome at the end. And work with it one-on-one. GDB. Raise your hand if any of you are in CS128. Less. What about CS124? That few? Are you guys ECE majors? Okay. Well, if you're in any class that has you okay, raise your hand if you're written programs in C or C++. Many of you. Okay, raise your hand if you've heard of GDB. Raise your hand if you use GDB to debug your programs. Okay, if you still using printf. You'll learn not to do that. All right. So in these compiled programs, they have different assembly architectures or computer architectures. And the two main ones you have to know about is ARM, which is, if you're on a Mac, you're probably running ARM, and if you're on a Windows computer, you're probably running x86. I tell you how to identify it. So you can do this now or do it later, but if you're on a Mac, you just hit the Apple icon on the top left and then hit about this Mac. It'll tell you. A lot of the instructions for ARM Macs on this slide are a little outdated because, as it turns out, I don't own a ARM Mac. You can see right here, it says Intel. This is my MacBook Pro right here, the 2020 MacBook Pro running Intel. But most of you will see something like this, Apple M1 or M and then some number. And that means you're on an ARM CPU, which makes things uncomfortable for pwn challenges and rev challenges, because often they'll be in x86, which means you can't just run the program. They're going to give you a binary, and some people will be able to just run it. If you're on a Windows computer, you can probably just run it. But if you're on an ARM computer and you try to run it, it will error. So you have to find some way around that, and we'll teach you some ways around that. All right. So installing Docker is pretty simple. If you're on Windows or Mac, I recommend just using Docker Desktop. You'll find the link here on your downloaded version of the slides. Just click it and then click download Docker Desktop, and then follow the instructions for Mac or for Windows. At this point, you should know if you're running Apple Silicon, that's the ARM, or the Intel chip like I have, that's the x86. Just click on the one that's appropriate for you. If you're on Linux, you probably already know how to install Docker, so I'll let you do whatever you want, but Docker Desktop will work on Linux too. Yeah. So GDB is the GNU debugger. We'll teach you more about how to use this in our Rev2 meeting, but just know you should have it installed. It'll help you in your classes too. They'll probably force you to use GDB at some point. Yep. This is another case where you just copy the instructions. If you're on Windows, you should be installing GDB in your WSL, not on your normal Windows context. So with a WSL terminal open, just copy these commands. And Mac will be more difficult to have GDB installed usefully. So raise your hand at the end of this meeting if you have an ARM Mac. And I'm gonna rush through these. You can read more about it. You can see this GitHub link. If you view it in your browser, you can read what's actually happening here. But this is just a little tool that SIGPwny as a club has written to help you run pwn or rev challenges in Docker. So if you're on an ARM Mac and you're running a binary that was compiled for an Intel or an x86, you run it with this thing. Yep. And again, we have a full CTF this Sunday. There's prizes, there's game badges, there's free food, there are recruiters, and there's fun challenges. So I recommend coming. And then next Thursday, we have our OSINT meeting. If you came to Seesaw, I think a lot of the newer students tried out the OSINT. We'll teach you how to get better at OSINT in general, and then also the CTF style OSINT chals. So I recommend coming to this meeting. It's probably the easiest thing to learn about if you want to do CTFs as someone new. And here's the main flag again. All right, so raise your hand if you downloaded the meeting slides off the website. Should be all of you. If not, do it right now. SIGPwny.com/meetings. Today's meeting, and you'll see download as PDF. And then make sure that you have Docker, pwntools, and Ghidra installed. And we'll help you through it. Just raise your hand if you have a question, a helper will come. Any general questions right now? Yeah. One-on-one. All right. Then yeah, raise your hand.
Like grass marlin.
Not grass and marlin.
Okay, so one of the first things we had you install was Java, and then also download Ghidra. So once you install Java and once you have Ghidra extracted, you'll have a sort of directory that looks like this. Again, if you're on Mac, you'll want to run this /Ghidra run in your terminal. So you'll need to cd into it. On Windows, it's a little bit easier because you can just double click this batch file. But if you double click that, it will open a scary command prompt because the NSA is going to hack you. But no, it actually just starts Ghidra. So if you see this window with everything, so you won't see a lot of binaries in here. I only have a bunch of binaries because I've reversed applications before. It will probably ask you to set up a new project. So you would do like file, new project, and then create a non-shared project. When I first was setting up Ghidra, like this is actually like my Ghidra project I first set up during my SIGPwny setup meeting back in like 2021. So it's very, very unorganized. But what you can do is you can make folders So you can like right click at the top, create a new folder. I recommend doing this, and then you can put like make folders for different CTFs. And let's just like, for example, go to like ctf.sigpwny.com. And right now we don't have any reverse engineering challenges up right now. So you'll see like we have our web and our intro meetings. If you click on the vaults tab, you can see all of our meetings or all of our challenges that we've ever put on SIGPwny CTF. You can sort of play these right now. But fall CTF will sort of look like this, where you'll have challenges separated by category. So don't be there will not be as many challenges on fall CTF, just to be clear, but you will see like fall CTF will have a rev category, a poem category, a web category. Generally speaking, the rev challenges, if you click on one and it has a download to a binary or something. So let me like try to find maybe Sewer Megacorp Day 3. So this has a download for a file. You'll notice that the file download doesn't have an extension. Generally, when you see that, that typically means in the context of rev or pwn, that means it's an executable application, a terminal application. If you see like something like a .zip or a .tar, you need to extract it first. But let's just like kind of look at this challenge. So I'm going to download third day. I'm also going to save in my downloads directory because I'm kind of unorganized like that. And then if you go back to Ghidra, you can do file and import file, and then navigate to your wherever you downloaded that, so you can yeah, it's because Ghidra really does that. So third day. Okay, we got it. So Ghidra will hash all that out, and let me see if I can zoom this in. I can't. Ghidra will ask you to import the file. It has some abilities to automatically detect the file format. So in this case, we can see that the format is set to executable and linking format, or ELF, or ELF. If you see an ELF binary, that generally means that it's a binary that you run in your terminal on a Linux system. So, and it also like figures out like the language. So the language here says x86. So we know we're reverse engineering an x86 binary. And then we can just click OK to import that in. So Ghidra will do this thing. It's going to show us results. And now the file is going to show up in your Ghidra window. And so if you double click it, it will open up a view to reverse engineer this program. When it first starts, Ghidra is going to go, the program hasn't been analyzed. Do you want to analyze it now? Click yes, because otherwise you're just going to be looking at assembly. So I'm going to actually click no here. You shouldn't do this, but I'll also show you how you can analyze a program if you do click no. So if you click no, you can sort of see like I have two panes here. The left pane is the assembly, or the raw binary in my program. So Ghidra will do its best to figure out what is assembly, what is data. And if you like scroll, like this is a very, very long window because there's a ton of stuff going on. And you see the right side is my decompiler. And the decompiler is going to try to take the assembly and turn it into readable C code. There's also a few helper navigation tools on the side here. The one you'll probably be using the most often is the symbol tree. And the symbol tree has this functions directory, which will basically list all the functions in the program. So probably the first place you want to start with reverse engineering is the main function, because the main function is the first thing that your program runs when it starts. So if we double click the main function, this takes us to the assembly view for the main function. Now, unfortunately, we did not analyze the program, so it doesn't show us any C code. So if you want to actually analyze it, you click analysis at the top here, and then click auto analyze third day. And then you can click analyze. And you can actually see here, there's a lot more functions getting populated now because Ghidra is doing its best to try to find all the function signatures, everything, and create the C compilations. So now you can see the assembly properly populates. And if I click on main again, you'll see on the right side, there is this wonderful C code, which doesn't look that readable, but Ghidra doesn't really know like a lot of the information, like the types of the variables in the program. So it guesses a lot. Like, for example, it doesn't know, like, it thinks this is undefined 8. So it's an 8-byte value, which it doesn't know what it is. But you can see there's things like, oh yeah, there's a call to puts and it'll print out, welcome to another generic flag checker. And if we look at our functions on the side here, we can see additional stuff like the call to puts, the call to printf. But if we look at main, this is where all our logic is happening. So you can see there's like a print, silly intern, that's not the right flag, or silly intern, clearly that's not the right length of the flag length. So from this, we can sort of infer that it's a password checker program. And if we run the program, we can see that. I'm not going to go into details of like trying to reverse engineer this program, but you can just sort of click around and look at the functions and see what the actual code is doing here. You could probably just copy this for loop and ask ChatGPT, hey, what does this code do? And ChatGPT will probably do a good job of figuring out exactly what it does. So again, if you were to try to run the binary manually, and like this is basically just trying to get the code that the program had originally and figure out exactly what it's doing. So that's Ghidra. That's why we use it. That's why we download it. There's a lot of different other tools for decompilation. So there's Binary Ninja. Binary Ninja is a paid version. It's very good. A lot of CTF players love it. We're actually being sponsored by them for Fall CTF, so they've given us 2 licenses for free that we can give out. So those will be available as part of the prizes. In the professional security scene, you'll also see people using IDA Pro, which is another reverse engineering tool. That one's very old and very well developed. But Ghidra is sort of the choice for a lot of people because it's free and open source. Does anyone have any questions about Ghidra? And this is just sort of a small introduction. We'll go more into Ghidra during Fall CTF and during our first reverse engineering meeting. So I just want to introduce the tool. We're not going to go too in depth with it today. Okay, does anyone have any questions with setup? Please raise your hands and helpers will be able to help you. But actually, show of hands, how many of you have installed Ghidra and have been able to open it? Okay, that's pretty good amount. And then one of the other categories which will require some tooling is pwn. So the pwn category is arguably the more difficult of all of the CTF categories. Again, because for pwn, you're going to have issues if you're running a NAC. So there's architectural differences. There's a lot of tooling and setup required. And generally, it's working a lot with the systems and binary exploitation, which is a little bit more complex than something like web exploitation or cryptography. So pwn has, in general with CTFs, what you'll see is you'll have a binary program that you're given, and you have to somehow feed it an input, which will let you run arbitrary code. So usually the way you would exploit pwn applications on a local system is you run the program, you feed it some inputs, and then it gives you a shell. In terms of flags, what people will do is they'll set up these binaries where if you connect to an IP and a port, it will run an instance of the challenge, and then it will let you send input over the network in order to exploit it. So this is why pwntools was made. It's basically sort of a helper to send these input over a network connection to the program. So it is a programming helper. I'm gonna make. Here, I'll go into SIGPwny. And what I'm going to do is I'm going to install pwntools in a virtual environment. This is sort of like how you're supposed to use Python now, but you can just install pwntools on your system as well. And let me try to find a challenge that might be good for this. So okay, format 0. Let's just do 0 overflow. So I'm going to download the source code for this challenge. And you can also see that it provided a like the actual built version of the challenge. So you can download that as well. And that is the application that's going to be running. And then it also there's also a makefile. So makefiles are basically files which will let you compile the program. So it outlines all of the libraries and the command that's required to actually build challenge.c into challenge. You don't really need to worry about it for now. The only reason we include it is for reproducibility purposes. So if I go into CTF, SIGPwny, temp, and I'm going to open this in VS Code, so it's a little bit easier to use. So if we look at the makefile first, so you can see that it's very simple. It just has a command which will actually build the program. But we are provided the program already, so that's not necessary. If we look at the source code, you'll typically see this setup function in a lot of pwn challenges. All this is doing is it's disabling buffering of inputs, which is kind of crucial for a lot of challenges, because sometimes you'll send something to a program and it won't actually get received by the application because the operating system is like pulling it because it wants to like read more. So this is all this is doing. Basically, we're telling the operating system, hey, if you get any input, give it to me right away, and don't like buffer anything. So there's a helper function here, which is print flag. It'll open flag.txt and then read it out to standard out, which is the output. And we also have our main function. So the main function has this character array of 40 bytes called name, and there's also this number which is set to dead beef. What we want to do here, it actually tells us, so if you can change the number to something other than 0x dead beef, you win. So this is a very traditional buffer overflow challenge. Essentially what we're doing is because of this call to gets, gets doesn't have the ability to figure out when a string stops. So you can write past the buffer for name, and that will corrupt the number. So all we have to do is write like a lot of bytes onto the challenge. So if I were to actually run this program, this is what it will look like. So I run the challenge program, it asks me to change the number. If I just type in like, min, it says the number is still that, so it fails. If I give it a lot of values, so this is definitely more than 40. I actually gave it way too many, so it segfaulted. But if I give it like just a little bit that it overwrites the number and doesn't overwrite some system values, it will do it properly. So if I do like 1, 2, 3, 4. Right, so that's 40 bytes. And now if I write just a little bit more, so 4 bytes for the integer, or maybe we'll do 8 bytes to cover the whole integer. Hold on. Okay. Hold on. We're getting there. Did I not count right? It just segfaults. Is it because I'm not running this right? I didn't compile, I just downloaded the challenge. So it should, if number equals not to be.
Like you need to have one less B.
No, it's well, no canaries. Okay, wait, that's not expected. Let's see. Okay. Okay, I think something's wrong with my system, which is preventing this from working properly. If we actually try this on the netcat connection, so I'm going to show us what it looks like here. So you're going to use netcat instead. Probably my system has some optimizations, which is preventing the we're just preventing the like the overflow from happening properly. So like if I were to actually put stuff here, it prints the flag because it actually runs properly on the target system. However, okay, so this is sort of so when I do this netcat connection, I'm connecting to an IP and a port, and our infrastructure is set up so it runs a binary, and it will forward the output to our connection, and then send the input that we send it to the binary. So this is a very simple example. However, think about the tediousness of having to, type out those AAA 4440s every single time. That's kind of annoying. So what we want to do is we kind of want to make this into a script that we can use. So this is what pwntools is for. So we're going to make a new file. Actually, what we're going to do, there's a tool called pwntools, which will sort of set up a challenge it'll generate a template script. But you can also just write the script from scratch. InfallCTF will likely give you a template script that you can just use with pwntools. So what I'm going to do is I'm going to run pwntools to generate this template script. And so we can see here it created a solve.py file. And what it does here is pwntools is the pwn library. So we import everything from the pwn library. It creates a copy of the challenge file, which is used to do manual patching in order to make it work in your system. So maybe it'll work with this. But it will set up a connection here. There's 2 parameters here. If I set this up to the remote connection, so if I go back to the CTF, I can see the IP and the port. So child.sigpwny.com, port 1387. I'll copy those into the script. And if I were to run the script now, it's going to default to the network connection. So I'm going to quickly use my virtual environment. And if I run the script now, I need to pip install pwntools. Yes. Well, yeah, you can also just install pwntools normally and break system packages if you're on a newer Python version. I do recommend using virtual environments, but I guess this is just kind of slowing me down. But pwntools is a lot of stuff to install, so it will do all that. Yeah, I actually probably have this working on like even Windows. Yeah, so I actually have pwntools installed on my Windows Python installation, so it just works fine. But pwntools will do all this instrumentation, and you can actually see, so what our main function is doing is it opens the connection to the challenge, and then it immediately puts it in interactive mode. So pwntools interactive will basically just say, okay, just start running the program. I'm not going to send any inputs. You take the wheel. So we can see the output of the command, and now we can type in stuff and it'll do it. So what we can do now is we can have pwntools send some information. So it asks, what's your name? So we want to send something right after it sends what's your name. So I'm going to like do this receive until and then send stuff. So the code I just wrote here is going to send 40 A's, and then it's going to send 8 B's, and the B's should overwrite the number. So if I run Python solve now, you can see it prints up the flag, because it sends the bytes over the network connection, and then it will basically execute that. And we immediately put into interactive mode so we can see the output. If we didn't do interactive mode here, it would actually not print anything, because the program would end immediately, and it doesn't have output enabled. If I were to put debug, pwntools will forcefully start showing all the inputs and outputs in a very verbose manner, so you don't miss anything.
Have you created a local flag file?
I didn't create a local flag file, no.
Would that be SIGPwny?
I don't think that's why that should be working, but we can try. So if we create flag.txt. Flag, test flag. All right, if I go back to, that is still installing, by the way. So don't use virtual environments, I guess. Here, if I were to run challenge. Okay, yeah, actually that was it. Thank you. Okay, so yeah. So it was actually SIGPwny, I guess, because they didn't have the flag file. But if you look at the code, what it does in order to print flag, is it reads this flag.txt file. I wasn't expecting that to segfault, but I guess it does. That would be a null pointer. Wait, so why is this? Yeah. No, I think this is just a really badly written program, but yeah, okay. I was not expecting the segfault, so, but yeah, so that's a very basic intro to Pwn. Again, this is the much harder side of the challenges on false ETF. So if you felt overwhelmed by this, don't, because there will be easier challenges, there will be web challenges, crypto challenges, and those will be a lot more fun to do. Yeah, it will be, okay, if you guys went to Seesaw this past weekend, don't let Seesaw ruin it for you, because Seesaw has really bad challenges. So policy TF will be much better, trust. Yeah, but yeah. But that's all for the demos for this meeting. We're just kind of showing off what you just installed, if you were wondering. So, yeah, we'll see you at Policy TF this Sunday. Yeah. So, somebody just asked if, we'll explain any of the policy solutions. So we don't have anything planned for that right now. What we might do is we'll publish some write-ups. We plan on taking all of the policy TF challenges and putting them onto policy TF. But if there's interest, we'll probably do a meeting on how to solve the policy TF challenges.
YubiKey said yes.
Maybe? Okay. That's kind of good.
They said yes, and then they started asking me questions. I think it's a yes though.
Awesome. Yeah, it works. pwntools works on Windows, like fine. Like,
Yeah.
When I install it on Windows, I can't import it.
How are you installed? Maybe is your pip and Python disagreeing or?
there's a chance, yeah, your pip is like using a pip from a different Python installation. What you might want to do is python-m pip install just to ensure it's actually working.
Yeah, so that would break a lot of things.
Yeah.
Sorry, I feel like you're from the audience. I have